Hello everyone, we will talk about sampling this week. We will have 2 lecture videos on sampling. This is the first part. So what is sampling? It describes the process you select your subjects. We have representative or probability sampling. It used to generalize the result to a larger population. Let's say you want to understand SFA students, how they choose their career path. Then if you want to have a representative sample, you need to randomly select amount of people that you like. Let's say 1,000 students, randomly select them. Then whatever they said may be representative to the larger population as well. We also have non-representative or non-probability sampling. You use this type of method when you're looking for a specific characteristic. Let's say if you understand the traits for art students, then you may want to only ask students who majored in art instead of randomly sample students from the entire campus or the entire school. The problem is when you're using non-representative sampling method, your result cannot be generalized to the larger population. It really depends on your research design, your research question. Then you will pick the appropriate sampling method. There's no sampling method that's absolutely correct in all situations. You always have to decide based on your real situation, the real design, and the specific questions you want to answer. And there is a difference between population sample and census. Population is the entire group of people you want to study. If you care about SFA student, then all the students form a population that you're interested in. If you are interested in all the adults in the US, then everyone living in the US who is older than 18 years old, then they are your population. It's important to clearly define what is your population because it's not necessarily self-evident. You have to say why this is the population you want to study. And the census means when the entire population is measured. You rarely get a census. It's very expensive to get an answer from everyone in your population unless you define the population so narrow that your population size is so small, but that may have other problem because your result will be really specific to this group and you can generalize it, then the relevancy of your research also decrease. So just keep in mind census is very rare, and if you define your population appropriately, you probably need some kind of sampling method to get the subjects. I have a graph here to show you the difference between population and the census. If you say my population is all SFA students, then you have to ask all of them your research questions or your specific questions you want them to answer. That will be a census. If you pick some of them, ask them the questions, then there will be a sampling method you use. How do you get a probability sampling method down? First, you must define the population, and then you want to use some kind of random number generator to select them randomly, or use one of this probability sampling method we will introduce very soon. As a result, you need to make sure that all members of the population must have an equal chance of being included. This is the most important part of probability sampling. If any of the members had a higher chance to be selected by you, then you don't have a probability sampling. This is really important. And sampling units can include individuals, groups, units, or sometimes even artifacts. Let's say the population you define is all the married couple living in Nacogdoches. Then your sampling unit is really a group, should be married couple. You don't sample individual anymore, so each couple will be one unit. Or you can study all the non-profit organizations in the US, then your sampling unit will be each organization. So it doesn't have to be individual all the time. Now let's talk about the types of probability samples. Remember, as a result, if you use probability samples correctly, all the members of the population should have an equal chance of being selected by you. The first method is called simple random sample. You just obtain a list of all population members and assign numbers to all members and randomly select numbers until desired sample size is reached. I got my PhD from Washington State. So if I want to study my old school, I will get the list of people there, all the students, their ID, and I will number all of them. And then I use a random number generator. Every time I click enter, it will give me a number. I will select that people, contact that person, and then keep going until, let's say, I hit the random number generator 30 times. I got my sample size of 30. So you can do that. And with phone service, not as much as cell phone. In the old days, when every home had a landline, you can use random digit dialing. And that's how phone service was done in the past, when you always had a landline. With cell phone, it's a little bit different. We will talk more about that later. So this is what it looked like. Let's say every spot, every square represents a person. The solid dot represents that person being selected. You can see the dots are everywhere. You don't see a clear pattern. And you don't really oversample one area over the other. So this is what a simple random sample should look like. The next step is called systematic random sampling. You can still obtain a list of all population members. Then you assign numbers to all the members. Everyone is represented by a unique number. And you randomly select a start position in the list. And select every kth element from the list. Let's say you have a population size of 1,000 and you want to have 100 people. Then that means you select every 10th person. That's how you get the K. So you randomly select a starting point, and from that person, every 5th, 15th, 25th will be in your sample. So again, use the figure, every square represents an individual or your sampling unit, and every solid dot represents this person is being selected. This is what they look like. If you go with every 10th, then the 1st and the 11th, then how you select them randomly from a starting point. And they can also look like this. You see a clear pattern and you cover the whole map, but because you randomly select the starting point, every member in the population still have an equal chance of being selected before you start the process. The other type of probability sample, more complicated than systematic sampling, is called the stratified random sampling. It's used to get a representation from a certain group. You divide the population into strata or groups. Strata are usually variables or characteristics of a group that are important to you. You want to make sure that those individuals are properly represented in your sample. When we're doing national election studies, we usually use race or ethnicity as strata, so we can have representation from each racial groups. Because when you get a random number generator, it's possible you miss some race and miss some ethnicity. So when you use strata, you can guarantee that you get some representation from each group. Again, let's look at the figure. Every square represents an individual, and the solid dot represents this person was selected. You can see among each smaller square, the 5 by 5 smaller square, each smaller square unit had 3 persons being selected. That's because we divide into strata first, and within each strata, we do the simple random sampling. That's how you got the result. This may be more helpful. It's a little bit, let me change it. It's okay, now it's perfectly aligned. Okay, that's better. So you can see within each zone, like each group, each strata we selected, there will be 3 persons representing the whole group. So stratified random sampling is more time consuming because you need to determine what are the groups first, and then you select within the group. It looks easy on this figure is because this is just squares. It will get more complicated when you're dealing with population, or sometimes in agriculture they want to divide the map, make sure that every area is represented. Then it won't be so straight lined or so squared, so cleared like the one I'm showing you. But this should tell you the gist of it. Okay, the next one is called multi-stage cluster sampling. You randomly select clusters, and the cluster people can base on the zip code. Let's say if we randomly have 50 counties in our population, then we randomly select a few clusters based on the zip code. and then we randomly select participants within the clusters. We use this method when you don't have a list of people. You don't have all their phone numbers. And you can also combine multiple stage cluster sampling with the stratified sampling. The differences here is that, let me show you the figure. See, you are selecting the whole cluster instead of each cluster have representation. So you see the two methods are slightly different. It really depends on what you want to do. And this is one stage cluster sampling. If you're doing two stage, it will look like something like this. You randomly select a few clusters first. In this case, we randomly selected 6 clusters first. Then within each cluster, we randomly selected equal amount of individual again. So this is called multi-stage. In this case, two-stage cluster sampling. When we're talking about a sampling method, we need to keep in mind that it's very hard to eliminate sampling error. Let's say this is a population. When you have if all your sample are from the guy with the red shirt on, then your sample is unrepresentative, of course. If you have person look like they're from every group, look like a random sample, but you realize some group is not represented in the second version here, then still your sample is unrepresentative. If you want a perfect representative sample, your sample should look like something here. You see the difference? But the problem is, it's very rare you have a perfect sample. There will always be some kind of sampling error. It just can be bigger or small. Even if you know when you flip a coin, you have 50% of getting the head, 50% of getting the other side. If you do it 10 times, it's very unlikely that you will get exactly 5 heads, 5 tails. This is just because probability doesn't always work out very perfectly. The probability will eventually become stable if you do it unlimited times, but that's in theory. In reality, it's just very hard to get a perfect sample. So researchers will use all kinds of methods to increase the accuracy of sampling. They try to match to the population, increase the sample size, and you can have smaller sampling error, but this process will take longer. You'll have smaller return rates and it'll be more time consuming and resource intensive. Okay, that's all I have for the first part. Let's take a break and then we'll come back to the second part of sampling lecture.